Alex, thank you so much. It is a joy to be here. It really is. I've only been here today, and what I've heard has just been so inspiring, so amazing. So thank you very much for the invitation. Rather than Alex having to do the introduction, I thought I would get ChatGPT to do the introduction for me. It doesn't make anything up. None of this is technically false or an hallucination or whatever. It misses really interesting and important stuff out. So I'm currently Professor of Computing Education at the University of Roehampton. Yes, I did say computing. Here I am at the Science Education Conference. Never mind. Okay, so my day job is training the next generation of outstanding teachers. It is tremendously good fun. Before that, 18 years across 4 different schools, 3 years as a head teacher, which was quite enough. Thank you very much. Roehampton let me out to do other interesting things, one of which was sitting on the panel that drafted the computing bits of the current National Curriculum Programmes of Study. That was great fun. The way we did this was inspired by the Royal Society, hello David's work on shutdown and restart, which said there's computer science, information technology, digital literacy. With due respect, we found it more helpful to think of that as the foundations of the subject, its applications, and then its implications for individuals and society. Turns out that's a really good model for thinking about AI education and AI in education. A whole lot about how does this even work, and then how can we use it usefully to get productive stuff done and save time and provide insights that we would not otherwise have had, but also what does this mean for individuals, for society, for jobs, for the very nature, I would suggest, of even knowledge. What I'm going to do over the next 48 minutes or so is talk you through each layer of this diagram, starting at the beginning with the foundations of this as how does this even work. So in my subject, over here in computer science education, any science that has to call itself a science isn't really a science, we have this model of we accept input, we process that according to a stored program, and we produce output. We have lovely examples of this. Here is one with which you may be familiar of what is this sort of mini beast, yes? I can answer a sequence of yes-no questions, and the computer can say, that's definitely a spider, or that's an insect, or whatever. I can write code which does that, as well as following a classification key. It doesn't have to be quite that simple. Over at Reading, they have the European Centre for Medium-Term Weather Forecasting, which does essentially the same thing, although on a slightly grander scale, probably with slightly more sophisticated code of let us take measurements about the weather on this incredibly detailed grid these days, pop that into an amazing supercomputer, turn the handle a few times, and then you get a prediction of what the weather is going to be, a pretty accurate prediction of what the weather will be like over the next 10, 15 days. Amazing piece of work, yes? Deterministic model. Of course, now it's all different, isn't it? So the link between input and output is no longer fixed by the program. It's no longer somebody typing lines of code, green text, black screen. The link between input and output is determined by some sort of AI machine learning model in there. Yes, that is based on data. We provide it with training data. Sometimes we label bits of that. Sometimes we say, just have a look at it yourself, see what the patterns are there. But it looks through that data, or we give it the labels, and then it produces, a particular algorithm produces that model. Our responsibility is to get the training data right and select the right model. But after that, the machine makes the connections between input and output for itself. I have not checked whether my audio is coming through the right thing. This may go horribly wrong. Let's try that one and see what happens. Peter Norvig, one of Google's AI engineers.
And so this is what we did. We said we're going to train this. We're going to give our system 10 million YouTube videos. But for the first experiment, we'll just pick out one frame from each video. And so you sort of know what YouTube looks like. We're going to feed in all those images, and then we're going to ask it to represent the world. And so what happens? Well, this is YouTube, so there will be cats. And what I have here is a representation of 2 of the top-level features. So the images come in, they're compressed, we build up representations of what's in all the images, and then at the top level, some representations come out, these basis functions, these features that are representing the world. And the one on the left here is sensitive to cats. So these are the images that most excite this node in the network, the best matches to that node in the network. And the other one is a bunch of faces on the right. And then there's tens of thousands of these nodes, and each one picks out a different subset of the images that it matches best. So one way to represent what is this feature is to say this one's cats and this one's people, although we never gave it the words cats and people, it's able to pick those out. We can also ask this feature, this neuron or node in the network, what would be the best possible picture that you would be most excited about? And by a process of mathematical optimization, we can come up with that picture, and here they are. Yeah. And maybe it's a little bit hard to see here, but that looks like a cat, pretty much, and that definitely looks like a face. So the system, just by observing the world without being told anything, has invented these concepts.
Do you not think that's oh, shush, no. Okay, I want to talk now. Okay, do you not think that's an astonishing thing from what is the nature of science? All it has done is look through loads and loads of data. In this case, it's YouTube videos. And it has inferred from that there is this common thing in many of these videos which we humans have subsequently labeled cat. This is just discovering the existence of cats by looking at loads of examples. What does that tell us about the nature of knowledge, the nature of science? Let me move on and show you another example. Next slide, please. Thank you. Okay, so, we now have Google's GenCast model is making even better medium-term weather stations than that vast supercomputer at Reading. How is it doing it? Not by, in any scientific sense, modeling the atmosphere, but just by looking at patterns in historical weather data. When the weather data had that quality to it, the subsequent weather was like that. That's different. That's not, here, I understand how the global atmosphere works. That's simply looking at the patterns in the data. Simply looking for patterns. And of course, the thing which we have got very, very excited about is what happens when that happens in language. Any of you working in schools where you give the kids iPads to write? I'm so sorry for you, but what you'll see there is when you ask the child to write something, they don't type. They start typing, and then they choose one of the three words next. It's fine for you guys responding to emails, that's not a problem. But when it's a child writing something on screen, this notion of the computer says, I'll call you in, well, I'll call you when, I'll call you later. It's a very small language model. We can take that a stage further, or a stage further than that. This is the Markov chain which lies behind this idea of the language model. Here I've given it the text of the Wikipedia article on Marie Curie, and I've said, just look at the two-word combinations, what we would call a bigram model, and generate me some text. Laboratory as units at field hospitals in her 1911 Nobel Prize would instead of her studies. It's gibberish, okay? But it is text. If we move that up to 3 words or 4 words at a time, it gets better and better. What you have now with our large language models, GPT and the other similar things, is not just the previous 4 words, but all of the previous words. From the first thing that you started typing in to all of the words in its responses, it takes all of that into account. Here in the GPT playground, you can start seeing some of the choices it's making. It starts with line 2 there. 2, machine learning. Machine learning algorithms can be used to what? It rolls the dice, sees what words are likely to come up next. Identify comes up 26% of the time in the language model. It got a low score, so it put analyze down and carries on doing that word by word. Folks, there are 2 consequences of this. One, it's not going to produce the same output each time. You give it the same prompt, you give it the same information to start with in your question or your first opening phrase, and it will produce a different answer each time because of the randomization that's involved. The other consequence, some of you will have said to kids in school, bad choices have consequences. Anybody? Okay, this is true here. If it chooses the wrong word, if it rolls the dice and put something which doesn't really make sense despite all of the previous words, or we call them tokens for no good reason, it will then put that word down and have to live with the consequences of that in all of the tokens that follow. So you get different output, and sometimes it makes stuff up. It's less likely to make it up now than it ever was, but it still makes stuff up. As I said, the training data matters. Please put your hand up if you have an account on Reddit. Thank you very much. Both of you. Three of you. Have you posted content out onto Reddit? Okay, somebody over there. Right, so thank you so much for training GPT-3. We're very grateful to you, because the links people have posted into Reddit followed those links, and they became a big part of Web Text 2 in our table there. So Web Text 2 is a big part of the training set for GPT-3. You may feel that the links people have posted onto Reddit isn't necessarily the sort of language you want your pupils drawing on, or you want to be drawing on when writing lesson plans. Some of you are old enough to remember when we said you can't rely on Wikipedia. Wikipedia is made up by people. Turns out now that being made up by people is not necessarily a bad thing, but there you go. Talking of people, there is a certain amount of human training in the process. So, the start of this is humans who work for OpenAI giving example responses to its prompts, according to whatever their corporate policy is. Some of this then goes on to saying, okay, I've got these two responses, which of these is the better one? And that goes into the weighting of the model and what it's going to respond next. And there's still an ongoing process of, it actually probably shouldn't tell somebody how to make a bomb, even if the prompt says, I'm writing a thriller which includes a character wanting to make a bomb. Could I have realistic? No, let's not go there. So there is a fine-tuning the policy enactments. The current, well, not the current version, but GPT-4, which forms the basis of what most of us are using at the moment. In the technical report that came with that, they said, this report contains no further details about the architecture, model size, hardware, training compute, dataset construction, training method, or similar. So despite the firm being called OpenAI, they are not being particularly open about their AI. This might give you pause for concern about using this to write exam papers or mock exam papers or whatever. Right, onwards. Let's think about some of the ways that we as teachers might use some of these tools. So the DFE, bless them, say teacher workload is an important issue. We are committed to helping teachers spend less time on non-pupil facing activities. And of course, we've seen so much evidence of that from the department, haven't we? We're working with the education sector and with experts to identify opportunities to improve education and reduce workload using generative AI. And joking apart, that's probably a good idea. Yeah, spend more time with the kids, less time doing things which a machine could have done for you. That's probably all right. There are a whole host of tools out there. This is the lovely TeachMate AI. Sits as an interface between the teacher and the language model. They don't have to type the whole prompt in. They click on the tile, provide it with a few parameters. It goes off and spins up a lesson plan or writes a letter or writes a report. Who else concerned about the machines writing a report? Never mind. Okay, there are other tools. This one is Magic School. I particularly like the teacher joke generator. We've all had that experience on the Sunday evening of, oh my God, I've not prepared my jokes for the week ahead. How am I going to find the time to do that? So it will generate a joke which is almost certainly less amusing than what the teacher would themselves have done. Summer of 23, the DFE do the consultation, because summer is the ideal time to get teachers to respond to a DFE consultation. How are you using this? They get 7 bullet point answers there. None of that's really surprising. I like the thing, though, below that about using it to proofread, edit, or improve written content. I do that a lot. I've written the thing. I feel it's my responsibility to write the thing if somebody's asked me to write the thing. But asking it, what have I forgotten, what have I missed out, that seems okay. This time round, they actually have got to, here are the things where we could fund some development work. So we have a shopping list, literally, of, what is that? That is 8 things on the list there of how the DFE could fund the tech sector to develop useful tools for teachers. I think it's a pretty good list, actually. And some of those things we're already seeing come to market, or at least be available in pilot stage. Let's walk through the process, or one approach to the process. Who in the room has used this to plan a lesson or a sequence of lessons already? Okay. I wish I had more time. I would love to come and talk to me later about how you found that. But, okay, so what do? I do this thing called resource-augmented generation. I don't just go in and say, plan me a sequence of lessons, just as I have learnt after 15 years in initial teacher training, not to say to my trainees, write a lesson plan. We walk through the process to get there. So I give it the secondary national curriculum for Key Stage 3 Science. I tell it that's what I've done, and I ask it to give me some specific learning objectives for that thing on the periodic table. And it actually reads the document and comes up with a not unreasonable set of concepts under some useful headings for that. Okay. I ask it a much more interesting question, which isn't in the national curriculum document, about, so what is it the kids don't know or have misconceptions about? Pupils think that the periodic table is arranged arbitrarily and based on atomic structure. Pupils might confuse periods with groups. I don't know if that's a misconception, but it's fair enough. You're going to have to make the point there as you're teaching this. I ask it if it's familiar with this lovely 5 E's approach, which seems quite common in science education, or at least seemed quite common in science education. Yeah, I know all about that because I have read all of the books and I have read the whole of the internet. Of course I know about this. And it says, oh yeah. And if you're still thinking about your periodic table thing, this is one way into that. I say, now use that approach. An outline plan for a sequence, a dozen lessons on the periodic table, suitable for a Year 8 class. And it takes this 5 E's idea really to heart and says each lesson is going to have that structure, going to have an introduction to the periodic table, the whole lot of 12. There's another prompt then, which says, can you show me this? Just tell me the lesson title and the key objective in a table so I can fit it all onto one slide. And you're the science teaching experts, not me. But naively, I think it's done a reasonable job about it. It's not awful, I don't know. You may wish to disagree. I'm interested particularly in lesson number 8 there. Chemical properties of metals and non-metals. Pupils describe reactions of metals and non-metals with oxygen and predict oxide properties. I think that's a really nice substantive lesson. Getting all of that done inside an hour's lesson is ambitious, but we've got robots to teach this now. How's it going to go about doing that? So my next prompt is, okay, let's focus in on that one lesson. Take into account all of the guidance we have from the DFE about what good teaching looks like, and write me an outline lesson plan. And in the middle of that, we've got half an hour of actual practical work, which is pretty cool, I think, isn't it? So we're going to need some magnesium ribbon, iron wool copper. We're going to heat some things. Heat a small sample of magnesium. What could possibly go wrong? Iron wool and copper in a Bunsen burner flame. We're going to record some observations. It's not a bad approach. Sorry, I'm not the expert here. If you think that's a really outrageous idea, please put your hand up now and come and see me later. Okay, anyhow, it's done this. Okay, this is great. Can you make me... who's working in a school where they have to do knowledge organisers? Oh, isn't it fun writing all of that? No, not so much. Okay, we have a machine which will happily write a knowledge organiser for you here. Can you give me a knowledge organiser for this topic? And it does a pretty good job of spinning up a knowledge organiser. There's an extract from that where it talks about the key vocabulary. I haven't studied this since I was 18, but I don't think it said anything which is outrageously ridiculous. Can I have that as a Word document? Yeah, here's the Word document. Go off and edit it. Put it onto your virtual learning platform or whatever. Assessment is so important, isn't it? I'd like an end-of-topic test on the whole unit, some retrieval questions, test pupils' ability to apply their knowledge and to think scientifically, use the guidance on Standard 6 from the ITT framework, and it's done a reasonably good job of wasting the whole of that last hour of my 12-unit thing so that they could answer some questions on it. Wasted it? I don't know. What do you think? Okay. Anybody doing this flipped classroom thing or has tried the flipped classroom? How does it go for you, sir? It's a lovely idea because you do the prep work before you come into the lesson, and then we get to spend the lesson on heating magnesium ribbon or chatting about big scientific ideas or whatever. The problem is, my experience is exactly the same. They never watch the video, they never do the reading. It's brilliant in theory, very, very poor in practice. My solution to this, find the great video, and we know that there are great videos available, get them to watch the thing beforehand, and then ask some questions based on this. So my prompt here was, write me 5 multiple choice questions based on the transcript of the video, such that you cannot answer the question correctly unless you have watched the video. So I'm not actually testing their scientific understanding. What I am doing now is testing whether they did the homework or not, which is kind of what we do in school. You don't have to watch the tape. It's a good tape, though. And then I say, make me this as a PDF. Not because I'm particularly wedded to PDF as a format, because once I have it as a PDF, I can take it over to Office Forms and say, turn this PDF into a quiz, multiple choice quiz, which I can place into my Teams thing or whatever it is that we're using to set this up. If anybody really is so bored that they want to answer some multiple choice questions, there's your QR code for this. And we get scores out of this. And I get to see at the start of the lesson who's watched the video or who knows enough about it to be able to convincingly guess the answers to these questions. And that, I hope, persuades them that they jolly well ought to have watched the video. So have we got anybody from Oak National Academy in the room? Okay, Oak did... Sorry, I had a sharp intake of breath. Oak was spun up during the COVID thing to provide online teaching based on what was regarded by Oak and GFE as quality lesson plans. Oak thus have a huge content base of detailed lesson planning, quizzes, PowerPoints, videos even. So there's a huge repository there inside Oak Academy. Oak have the cunning idea of, we could use this to fine-tune a language model. They've come up with like a 9,000 character or word prompt, which will produce lesson. This is different from me, non-expert, coming into ChatGPT, saying, read the national curriculum, read the core content framework, write me a lesson plan. This is now based on what has been assured by some in authority as quality content. It asks me really, really good questions. It says, look, I don't have to do another lesson about metal and non-metal oxides. I've written one of those already. Do you not just want that one? I say, no, go and do the whole thing again because, well, you know, carbon footprint. And it goes off and does all of this work and produces, I think, a pretty good lesson plan. If you buy into Oak's approach to these things, then, you know, it's split it up into these 3 20-minute learning episodes or learning cycles. It's got a quiz that goes at the top of the lesson. It's got a quiz that comes up at the end of the lesson. It's identified misconceptions, probably better than I did just with that 0 or small number shot prompting. And it will happily produce you a really quite dull PowerPoint deck of slides, which you can then add some interesting illustrations to if you would like to. Okay, anybody tried Suno yet? Suno is a music generator. You're only allowed to prompt 200 characters, which is not enough to describe everything a child should know about the properties of metal and non-metal oxides. But I asked it to write a song based on this. I included the word metal in there, which in retrospect it has paid the wrong sort of attention to. I will not, I hasten to add, play the whole of the tape for you. Here we go. All together now. And, you know, if you're asked to do the assembly on Monday, there you go. Something science-related for the assembly is fine. Okay, let me move on, please, to thinking a little about how your pupils, how your students might already be using some of these tools, might be able to use some of these tools. The DFE, bless them. The education sector needs to teach students how to use emerging technologies, such as generative AI, safely and appropriately. If it were me, I would have included ethically in there, but you might wonder why the previous government didn't. Never mind. Okay, so, you know, we've got things that we jolly well ought to cover. Yeah, this is going to be part of the world that we are preparing them for. What does it says in 2002 Act? About the opportunities, responsibilities, and experiences of later life. AI seems to be part and parcel of that. So what are you going to do about this? Well, bearing in mind that the terms and conditions apply. Primary schools, there is no tool out there online that they could legally use. Secondary school, above the age of 13 with parental consent, a number of these tools are available. There are other ways. You can install a language model locally, but good luck persuading your network manager that you need to do this in order to teach kids about these things. So there are issues there. You know as well as I do that we have children, some children, below the age of 13 who have signed up for social media accounts by lying about. I know it's astonishing, but it has happened, yeah? So it is possible that there are kids who have lied about their age in order to get access to these tools. There are also going to be loads of kids whose parents are almost as geeky as me and are showing children what they can do with these things. So there are ways. There's stuff you can do at the front of the room anyhow. This thing about from practical work, do you do the demonstration or do you let them do the practical? There are things that we should make them aware of, and I'm really bothered about the first one. Is it the My AI inside Snapchat, which pretends to be your friend? Oh, you mean you're stressed about your history homework? I could do your history homework for you. Okay, it's history. We're not worried. But so this sense in which they, because they don't yet have a fully formed theory of mind, might be persuaded by somebody who is helpful and articulate and takes an interest in them, that I could have a relationship. No, you can't. It's a machine, really. It is just a machine. I don't think it really understands, although it clearly can figure out whether there's a cat in a video. It can clearly tell me what the weather's going to be like in 15 days' time. It is getting better and better and better at maths. There is a sense in which it's not aware of its own limitations. It feels like one of our sixth formers who just, of course it's this, it must be this, but actually recognizing the gaps in their own knowledge. Anyhow, so here you go. My daughter is in year 9 at the moment and is dyslexic and is learning about the life cycle of stars. I think that's awesome. I really do. And weirdly, I appear to have access to her notes. So here on the left-hand side, you have her notes about the life cycles of stars. I asked ChatGPT, read through my notes here, and a really targeted prompt about what have I not understood? What are the possible misconceptions that you can see from my notes? A child who can use it in that way, not to write the notes about star life cycles, that's not helpful. But read through my notes. Don't bother about correcting my spelling mistakes. I'm not good at spelling, yeah? But tell me about what the big ideas are that I've not understood about this. And you have to be pretty good at astronomy or space physics or whatever to be able to pay that much attention to detail in a set of notes there. For biology, she had like biology exam, end of the autumn term, and they send her 30 pages of notes to revise for a 45-minute exam. I think any child, dyslexic or otherwise, is going to take longer than 45 minutes to read through 30 pages of notes. However, Daddy knows about NotebookLM. So what we do is we ping all of the revision notes her teacher had helpfully, nothing wrong with having the revision notes, there really isn't, to NotebookLM, and say, could you please provide me with some study materials based on this? And it does really useful things, so I can get from this, give me a knowledge organizer based on this. So here we take 30 pages of revision notes and get them down to 2 pages of just tell me the key information. Her teacher could easily have done this for her, and that would have been a helpful thing. And I can go a stage further. Here's a short revision quiz based on the resource you provide, and she can practice answering these questions, and hopefully some of them will come up. Who's used NotebookLM before? Very good. People at the back. That's fine. So the really exciting thing about NotebookLM is it will produce a podcast based on the source material. Way less likely to hallucinate in any of this because you've given it the content to work from. And here we go with two very enthusiastic people helping my daughter revise for her biology exam.
Right, so we're diving into some biology now. Camouflage, animal senses, hormones, and nutrition. Should be fun.
Definitely. Should be a good deep dive.
Yeah, definitely. Okay, so first up, camouflage. You've got all sorts of types. Counter shading, background matching, disruptive coloration, even mimicry, costumes, and olfactory camouflage.
I'm not going to play you the rest of it, but it is so much more accessible, not just to my daughter with her dyslexia, but to the rest of her classmates. Those 14 minutes, not as much information, but more, I would suggest, more likely to be retained. Waves hands because he has no evidence to support the claim. Never mind. Okay, right, on we go. So this is taken from OCR's examiner's report. This is an example of what a young person wrote in response to the question on the left there. You know, there is an exercise for the audience as to what mark out of 6 would you have awarded that. It is deeply dodgy for the exam board or for you even as a teacher to take an answer to something like this and ask ChatGPT, what mark should this have, or what feedback would you give? I'm happy to talk about why. On the other hand, I have no problem with the teenager themselves taking a photograph of the question, taking a photograph of their answer, asking ChatGPT or one of the others, could you give me some feedback on this? Could you tell me how I could have improved this answer? And it will give really detailed feedback on this and even gives a model answer which keeps to the theme of what the person had written in that sample of work there, but sort of tidies it up and strengthens the evidence base on which it draws. Okay, so there's a line in Key Stage 3 of the science curriculum which says children should be taught about, or children should learn, the production of carbon dioxide by human activity and the impact on climate. We have, at Sutton Bonington, which is part of this university, climate records or weather records which date back to 1961. Every month since 1961 we know what the minimum and maximum temperatures are. They're on the Met Office site. That is a cool data set, yeah? If you've got something similar in your school, do your school's record, but I would be very impressed if you had it going that far back. Okay, so I say to chat, getting from there to something that's meaningful is doable. We can do the spreadsheet lessons. We can teach how to go from this table to some meaningful visualization. Or we can just ask ChatGPT to do this. This is a thing a pupil themselves could do. Create a clean, tidy table of this, 1 row per month, 1 column for each of the observations. And it has to have 3 goes at this. This is hard, even for the vast machine intelligence to do this. Thank you. Add a new column for temperature, the average of Tmin and Tmax. Calculate the average annual temperature and show this as a new table of year and temp. Then show me a time series plot, year horizontally, temp vertically. Add on a line for the 5-year rolling average. Would you like to use your finger and the air in front of you to sketch what you think the graph will look like, please? Okay, this is where I need a video of my audience. Never mind. Okay, here we go. So this is what we get. The gold line there is the actual annual temperature. It goes up, it comes back down. There are warm years, there are cold years. The dashed line is the 5-year rolling average, and I'm reasonably confident that since 1997, that has not been below 10 degrees. Until 1997, it was never above 10 degrees. We've got, this is a science lesson, isn't it? What does this tell us about temperature over the last 60 years? You could ask for another visualization. So I could say, okay, let's see this as a heat map. Color these in as vertical bars, do red shading for the hot years, do blue shading for the cold years, and we get that. I can do it in Excel. Of course I can do it in Excel. But pupils can do it for themselves. Again, my 14-year-old daughter, we are doomed, aren't we? Well, let's be optimistic about this. Okay. Use the Keeling curve data. Give me a table of year and CO2 concentration. Add that in as a new column in that table of the Sutton Bonington data. Oh, sorry, here is the Keeling curve about how CO2 has changed over the same time period. It appears to be going upward. Again, science education is not my area of expertise, but I think that is an upward sloping graph. Okay, so now do me a scatter plot of CO2 concentration against temperature. Correlation does not imply causation, but some other explanation? And you want pupils thinking critically about this, but you also want pupils being aware of the evidence. That's one line from the science curriculum. Oh, and then the simulation thing. I don't know. So what is the model for, this is using Claude, what is the model for the position of a mass on a spring under gravity? And it tells me about how this is, and it gives me the equation of motion there, and then we'll do some more work with that. Then I say, could you make for me an interactive simulation of this? And I need to reload this because it just keeps running in the background here. And I should be able to pull the mass down, maybe. And we see the thing bouncing with a bit of luck. It's bouncing rather slowly. I think they've reduced gravity for the sake of clarity here. Is it hallucinating this model? No. It's shown it's working. I can inspect the code that it has produced. But if there is something where you wish there was an interactive simulation, or your pupils do, they can easily make one for themselves with this. Okay, I want to use the last bit of my time with you to talk about some of the broader issue. Oh, let's just do this one first. I've told you she's dyslexic, not science. For her classics homework, they set her, could you write an obituary of Hannibal Barca? You know, Hannibal with the elephants, Second Punic War, crossing the Alps, not your area of expertise, not mine either. So she gets ChatGPT over the age of 13 by this point to write an obituary of Hannibal Barca. It's fine, it does that, it's brilliant at it. She, smart cookie, knows that her teacher will know that's not her work. Yeah. Write an obituary of Hannibal Barca as if dyslexic, adds in loads of random and unimportant spelling mistakes. Just like my heavy metal oxides thing, it throws in, it's misunderstood. So it said, if Hannibal were dyslexic, what would his obituary be? Hannibal's legacy will live on, reminding us that even in life's typos, there's beauty and humour. The contemporary historians do not record whether Hannibal was dyslexic. It was very hard to get an EP assessment back in those days. Oh, something's changed. Okay, so broader issues. Where would you draw the line? This is show of hands, folks, here. So do you think it is cheating if your pupils get ChatGPT to explain something to them? Hands up if you think that's cheating. Is it cheating if your pupils get ChatGPT to give them ideas for their homework? Is it cheating if they get ChatGPT to suggest how they could improve their homework? If it were coursework, yes. Homework, I don't know. I want to see what they can do on their own. And their parents would never help them with their homework. We know. Okay, so is it cheating if ChatGPT writes their homework for them? There are people who have not put their hand up for that bottom one. So yeah, I think pretty much every audience, from 5-year-olds up to people such as yourselves, draw the line in the same place. And I think there's a good reason why. If one of your pupils comes to you and says, Miss, Sir, could you explain this to me? Generally, you will do that. It's kind of on the job description. You don't really get much option. Will you give me some ideas for how to start with my homework? Well, generally, you will say, have you actually read the worksheet? Have you read what the instructions? But then you will help them get started with this. Miss, Sir, I've had a go. Could you have a look at it and see how I can make this better? Very few of us have the time in our day to do that when we would want. But if a kid is so interested in the subject that they have come to you and asked that question, most of us will make the time. If the kid comes to you and says, Miss, Sir, could you write my homework for me? I think they know what the answer is going to be. So if they're used to getting that help from their friends, their parents, their teachers, why not also from the AI? I think is my argument. Clearly there are rules. If it's something which is part of the non-exam assessment, they cannot get the AI to give inappropriate help with this. JCQ's rules, teachers and assessors must only accept work for assessment which they consider to be the student's own. JCQ, the body of the awarding organizations, is placing the responsibility of this onto you as schools. How will you assure yourself that this is the child's pupil's own work? Short of bringing them in and watching them whilst they do this, kind of defeats the whole argument for coursework. So Ofqual, as the state's regulator for this, says we need to know, is there widespread malpractice? Are kids using GPT, etc., to cheat for non-exam assessments? Let's ask the awarding organisations if they think there's widespread malpractice. Awarding organisations, we know there isn't because the schools have handed in the coursework and the schools know that they cannot hand in coursework which isn't the pupil's own. There's kind of a don't ask, don't tell thing going on here. Of course, it's fine. The awarding organisations say, it's fine. The awarding organisations, the schools say, it's fine. The kids say, it's fine. Of course it's fine. I suspect this may be underreported, I think. As yet, Ofqual's rules are that awarding organisations still have to employ people to mark exam papers. Those of you who have some busy weeks at the end of the summer term marking exam papers, you're fine for a little while yet, but I wonder how sustainable that is. We don't yet trust it enough to make those decisions about what grade does this child get. Okay, then you get this. Who's working in a sixth form or teaching people A-level, sixth formers, etc.? Okay, please don't do all you can to discourage them from getting the machine to write personal statements. I type in as my prompt, I'm studying all three sciences at A-level. If you help out with the local wildlife trust at the weekend, I've completed my Duke of Edinburgh award. Write me a 500-word personal statement for applying for a biology degree at university. Yeah, there you go. Is it a personal statement? No, of course it isn't. And admissions tutors will be reasonably able to tell. We would very much like folks, like folks to come and do biology at university. It's a good subject, loads and loads of career options. So I don't know, but what does that say about ethics and integrity and the sort of person you're about to admit onto the course? GPT-0 says, that seems 89% likely to be generated by an AI. In this case, I know that it's 100% generated by AI. You guys have really good advice on this. So you can use it for some things, that's fine. Brainstorming ideas, helping with the structure of the statement, checking that it's actually readable and makes sense, that's fine. Anytime you find yourself doing Control-C, Control-V, probably not a good idea. It's meant to be a personal statement. The state has regulatory principles about this, which I'm not going to talk through in detail. Ofsted, as one of the state's regulators, are responsible for putting those in place across schools. The left-hand side is what that means for Ofsted as an organisation. And they say elsewhere in this report, they won't use generative AI to produce inspection reports. That's decent. Yeah? You may well feel they're written by machines anyhow, but no, they're not going to use generative AI to do this. But on the flip side, they're expecting schools to follow these principles too. So only use AI solutions that are ethically appropriate. We expect providers to consider bias relating to small groups and protected characteristics before using AI. And we go, Ofsted, I think, going to do little survey visits of how are you using AI? Is it helping with workload? Talking of bias, on the left-hand side of my screen are photos of a physicist. On the right-hand side of my screen are photos of a physics teacher. What do the 8 people depicted all have in common? Men. There is also a higher than average proportion wearing spectacles and a vast number of beards out there. So, this is not what all physicists are like. I know this from experience, okay? But, it's looked at pictures that are labelled physicists and thought that's what people want if they want a picture of a physicist. Next slide is biologist and biology teacher. What do you think will change? Yeah. Left-hand side is the biologists. Right-hand side is biology teacher. There is a thing going on in picture 3 of biology teacher about waistcoats. I don't know, it's clearly a thing. Science teachers wear waistcoats. And the gentleman at the top left of the biology teacher, I think, is also being employed as a physics teacher. I don't know, I suspect it's the same. You multitasking key stage 3, you know how this is. The stuff I am really very concerned about. You know, I've given you the climate change thing. We've done the warming stripes visualization. We've done the scatter. But I just worry about how much energy I've used to give you this talk this afternoon, how much carbon dioxide I've produced through all of these service centers spinning up to produce images of biology teachers and physics teachers. This is a presentation not without cost. Was it worth it? No, I hope so, but you know, you remember when we used to tell them to think before they click when they did anything online? I think we need to bring that message back when it's using ChatGPT. There are times when it is an entirely appropriate, an entirely beneficial thing to do. But just saying, oh, I can do all of this. Yes, it can. That doesn't mean to say we should let it. Okay, so remember, 2002 Education Act, preparing them for the opportunities, experiences, and responsibilities of later life. Sal Khan, who founded Khan Academy, entering a post-scarcity world. If you want text, if you want pictures, if you want heavy metal music, if you want video, we can do all of that. If you want code, we can do all of that essentially for free now. You have to be able to read or code well enough to put the pieces together. There are likely to be other jobs that are very human-focused. So I think physics teacher and biology teacher and chemistry teacher, remain on the list of stuff that people will still do. But the interesting question for me is, what about research physicists? What about research chemists? What about research biologists? Is that something which becomes something that the machine does? It's weird at the moment. There is a whole sort of, how does this work going on? The machine produces this output. I tried to explain some of what's going on behind the screen when it does it. But we have researchers who work in the field saying, it's kind of alchemy now. If we do this, it does that. We can't really explain the steps in between. It's a black box. Why does the machine learning model produce that output? Because the machine learning model is in that state when we ask it, because that's what the weights of the neural net are. Sora, which is not yet available in this country, is going to produce amazing little video clips at, I suspect, a vast environmental cost. In order to produce a video of two ships sailing across the top of a cup of coffee, it has to understand. It has to be able to model physics. It has learned how to do that by watching YouTube clips and watching computer game output. It has come up with some internal model of fluid dynamics and gravity and energy and momentum and all of the rest of this without actually learning the science or being taught the science. It's inferred it from the data. And then we get AlphaFold. Is there anybody in the room who can explain protein folding to the audience? In less than a minute. No, 11 seconds, according to my watch. Look, protein folding is a hard problem, yeah? We know the amino acids. What we're interested in is the structure of the protein. It's taken 50 years and we still can't do this, despite spending a lot of equipment and grant money on lab equipment for this sort of thing. Along comes DeepMind at Google and says, yeah, that's not a problem. We can work that out just by looking at the data and what happens. We can make the prediction in the same way as we can write poetry or very, very bad heavy metal music. Last thought to leave you with. Memory is the residue of thought. Unless you, or I think more importantly, your pupils, are thinking about things for themselves, the chance of them ever remembering it is significantly reduced. Yes, it can do all of it, but the chance that you learn it from it just does it for you, I think, is slim. I have had a great time here. Thank you very much for listening. I'm going to hang on if anybody wants to come up and argue with me, but I'm conscious that I have deliberately not left any time for questions.
Well, I'm going to be a bit mean because we do have a bit of a break.
Oh, no!
So we could spread into this, and we do have about 3 minutes. So there we
Yes.
go.
Sorry,
Sorry, Miles.
Oh, well.
So,